Hey guys, what's up? My name's Henry, and today we're going to be going over the practical uses of reading an input from an Arduino through Snap from an Arduino. Let's get started.
You're going to need an Arduino, a jumper wire, a button, a 200 ohm resistor, and an LED.
Now, first thing you want to do is make sure your Arduino is connected, so let's get that rolling. Go ahead and go to your snapforarduino.rocks website on Google Chrome and scroll down to Play Online. Now, if you haven't already installed the extension, please go ahead and do so. Otherwise, your Arduino isn't going to be able to connect to Snap for Arduino. But if you have, please feel free to continue with this tutorial. So we're going to go ahead and play online, and in a moment, you'll see your function panel pop up here. You have motion, looks, and there'll be a tab called Arduino. So we're going to go there first. Now, you'll notice if I go to connect Arduino, I have two COM ports listed, COM4 and COM5. But once I plug in my Arduino, and I'm going to do that on the side here, you'll notice I get an additional one, COM7. So most likely my Arduino is there. Now know if you're a Mac user, your COM ports will be listed differently. You'll have /dev/ whatever might occur afterwards. It's the same thing. Mac just deals with it differently than Windows. We're going to go ahead and connect to COM7. That'll do its thing. And we have been connected. So to read a digital input, what you're going to do is first off, take your jumper wire, and we're going to connect it to pin 8 over here. 8 is on the right side. You can see it here. And we're going to go ahead and connect that to ground, all the way on the left side. So this little jumper wire will stay right here. Now we're going to go into our Snap for Arduino and pull out a digital reading. Now I want you to read the 8th pin. And if you go ahead and click on it, you'll notice it's false. And that's perfect because we've grounded the wire, which means it should be false. Now what happens if we switch it to 5 volts, right? We should expect this reading to be true, which is great. So we have this wire that's acting as a button. We get true values and false values depending on the grounding and depending on the voltage we feed to the 8th pin. That was a lot of words all within one sentence. So let's try to break this out a bit. So if we get rid of this wire, and what I'm going to have you do is put it in an actual button, okay? So what I want you to do is plug one end into the 5 volts, the other end into pin 8. Now I want you to take the 200 ohm resistor, and we're going to make something that's called a pull down resistor. It, if you want to look at it this way, pulls down the voltage. So go ahead and put one leg of it into pin 8 and the other into the grounding that's right next to 13. And I'll give you a better shot of this in a moment. So here's what it should look like. You have grounding for the resistor. You have one lead of your button in 8, and you have another lead of the resistor also in 8, and then you have another lead of the button in 5 volts. Now we can play around with this in Snap. So right now, if we get a digital reading, it should be false. Once we press the button, you'll notice it's true. Now this application is great for seeing how this button works. So what we were doing with this wire, was physically moving it between 5 volts and ground to get our true and false values. But with this setup, we can have an actual button that is either in a 5 volt state or in a 0 state. So either in a false state or a true state, a yes or no. All of this is binary. So that means we have two options. We have our true or false, we have our yes or no, we have our on or off. That's how binary operates. Now the cool thing about this is we can change our hardware, we can control our hardware with this button. So we're going to go ahead and make an if statement. Let's go into controls, and if you pull out the if-else condition, you can say if my reading is true, so if I am pressing the button, what we're going to do is turn on pin 13. Now pin 13 is special. It is the only pin on the board that not only has its own breakout right here, so its own pin setup over here, but on the board itself there's an actual LED tied to it. So check this out. So if I were to take this out of the loop, or out of this if statement, and turn it on, notice how that LED is now on. Now if I turn this off, it goes off. On, off. So we can throw this into this if statement, and we'll say if I'm pressing the button, we want this LED to be on. If I am not pressing this button, so else, otherwise, then for pin 13, I want the LED off. Now to tie this all together, I'll put it in a forever loop. So once it starts running, it won't stop until I tell it to. So we're going to go ahead and run this. Now notice the LED is off. Now when I press the button, it comes on. Off, on. And if you want to see this a little bit better, I asked you to pull out an LED. Now, you were told that the long end is the positive and the short end is the ground. So let's go ahead and do that. So go ahead and put the long end into 13 and put the short end into ground. The same ground that your resistor is in. It's going to start to feel a little messy, but that's fine. So now when I press the button, it's on. Now it's off. On, off. Now that's just a great way of demonstrating how digital pins work and how you can interface it with the actual hardware. I hope you enjoyed the video. I hope you learned something, and definitely catch us in the next one.